All right, well, we're in chapter section 2-1, power and radical functions. And I'm over now on page 87. This is example 1 to analyze monomial functions. And we're being asked to graph and analyze a couple of functions here in the guided practice here in example 1. And so the first function that we're asked to graph and analyze is the function, power function, 3x raised to the 6th power. Now you see over here on the left, on the screenshot, this is a screenshot of the graph. I went into the TI-84 calculator and I graphed 3x to the 6th. And this is how my graph appears. And I was using window settings of for x minimum -10, x maximum 10, x scale 1, y minimum -10, y maximum 10 with a y scale of 1. And so this is how the graph appears at 3x raised to the 6th power. Now, when we're asked to analyze this, we're asked to consider such things as, one, the domain. Now, if I'm looking at this graph, when I'm looking at the domain, I'm trying to determine, okay, well, what x values do we have? And if this graph, in particular, if I were to go look at a table, well, here I see x going out to -infinity and y going out to, x also going out to +infinity. So my domain is -infinity to +infinity. Now, what about my range? Well, again, I'm looking at the graph, and so the range being the y values. And what do I see out of the y values? Well, I see that I've got a minimum here at 0, right here, and y then is going out to infinity, and y is going to infinity. So my range is 0 in this particular function, 0 to infinity. Now, what about intercept? And here we're talking about x-intercepts. Well, I see an intercept here. I see that the graph touches 0 right there. Doesn't go below, but it does touch that x-axis there at 0. So my intercept is 0. The next piece that I'm going to analyze is in behavior. Now, imagine, if you will, and because this graph doesn't show it, that at the top of the graph we've got little arrows going up. In this particular case, the arrows are going up. In other words, it's continuing on above what we can see on the graph. And so I can conclude from this that as x approaches -infinity, x is going this way. What's y doing here? Well, or f of x equals to y. I can see that y is going out to +infinity. And at the same time, I can see as x is moving towards infinity this way, f of x or y is also moving out towards infinity. And so I'd express that this way. The limit as x is approaching, that little arrow right in there means approaching. As x is approaching -infinity, f of x is equal to infinity. And as x is approaching +infinity, well, f of x is also going to infinity. Now, the next piece we're supposed to analyze is whether it's continuous or not. Do I have a break in the graph? If I were to take a pencil and trace that graph, do I have to lift my pencil? And I do not, so therefore it is continuous for all real numbers. And then the last analysis that we're going to be looking at is in behavior. Not in behavior, but whether it's decreasing or increasing. And when I do that, I'm going to look at the graph and read it, if you will, from left to right. So I'm going to start up here, and I see that as x is in -infinity territory, and I'm coming down, well, I'm decreasing until I get to 0. And then when I get to 0, I turn. I'm still reading this graph left to right. I turn at 0, and now we're going up to positive infinity. So there we are. We take the graph 3x to the 6th power. The domain's negative infinity to infinity. The range is at 0 to infinity. I got an intercept at 0. I have an end behavior such that as x is approaching negative infinity, f of x is equal to infinity. And as x is approaching positive infinity, f of x is equal to infinity. My graph is continuous for all real numbers. It is decreasing as x is going towards negative infinity to 0. At 0, I see a turn. Now it's beginning to increase from 0 up to infinity. All right, there we go. We'll take a look at one more. Okay, so we're continuing on. We're graphing and analyzing monomial functions. And this time we're being asked to graph negative 2/3 x raised to the 5th power. Now, again, you can see here on the left, I have in fact graphed negative 2/3 x raised to the 5th power, and it appears such as what we've got right here. And again, we're going to do the same thing. We're going to be looking at domain, range, intercepts, end behavior, continuity, increasing, decreasing. So let's take a look at what we've got on this graph. Now, from the domain, again, I can see that as x is going out here, x values are going out here, negative infinity. They're actually going out here, positive infinity. I would see this more clearly if I went into the graph and actually looked at the table of values. So our domain still is negative infinity to infinity. Now, what about our range? Here I can see that I've got y values that are going out to infinity, and they're also going out to negative infinity, unlike the graph that I saw before, which was an even function. This is an odd function, and I would actually expect the graph, in fact, it's an odd negative function. I would actually expect the range to be negative infinity to infinity, and I can see here from the graph that that is in fact the case. I got range values going out here to negative infinity. I've got them going up here to infinity. Now, again, we want to look at the intercepts, and both x and y intercepts. I think I said only x intercepts in the previous slide, but that particular one, that even positive function, had an intercept at the origin, 0, 0. And I can see here that the same is true on this graph. I mean, it looks like it's really close, and if I were to go into that table again, I would see that it really hits 0 right there at the origin. So my intercepts are at, both for x and y, are at the origin or at 0. And also, once again, we're going to take a look at end behavior, and I want you to again to imagine that I've got arrows going in this direction. So I'm looking at where's the movement of this graph as it goes beyond what I can actually see in this case. Well, I can see here that as x is approaching negative infinity, as x is going this way, f of x or y is going to positive infinity. So as x is approaching negative infinity, f of x is going to positive infinity. And over here on the right side of this graph, as x is approaching positive infinity, well, in fact, y, or f of x, is going towards negative infinity. So here again, I've got a limit where x is approaching negative infinity, f of x is approaching infinity, and as x is approaching infinity, well, f of x or y is going towards negative infinity. Now, what about continuity? Well, again, continuity is such that if I can trace the graph with a pencil and trace it without lifting that pencil, it is continuous for all real numbers. And so I don't see any break in the graph. I could, in fact, trace it. So it is continuous for all real numbers. And let's see, lastly, we're going to talk about increasing and decreasing. Now, remember, on increasing and decreasing, I'm going to be reading the graph from left to right. And so I'm starting here, and I'm decreasing, decreasing, decreasing. And I make a little jog right there, but I'm still decreasing all the way. And so I am decreasing as x is going towards negative infinity as well as positive infinity. I see no turn in the graph. I do see a little jog, but I never change direction. If I'm reading this graph left to right, I'm continually decreasing. All right, there we go. We've analyzed that type of function, both even and odd. We're next going to take a look at functions with negative exponents. Now, before we get there, if I've got a negative exponent, it actually makes that function a reciprocal function. And we should remember that on a reciprocal function, I am going to have some discontinuity among some other things.